Good morning children. Today we are going to start IIT Physics, the chapter Kinematics. Before going to know what is kinematics, let us know what is mechanics. Mechanics is a branch of physics. It's a branch of physics which deals with motion of bodies. Mechanics is a branch of physics which deals with motion of bodies. Do you know children, when a body will execute motion, there should be some force applied on the body. For example, if take an object, if you apply some force, then the body will be in motion. So, here mechanics is a branch of physics which deals with motion of bodies. When you apply some force, the body will execute motion, children. So, now our chapter Kinematics is our chapter Kinematics is a branch of mechanics which deals with motion of bodies, in which force is not considered. That means, let me explain, in which force is not considered, in which the cause for the motion is not considered. For example, if I throw the object like this, it is falling down due to gravitational force. Such kind of motion are dealt under kinematics. In kinematics, the cause for the pen to fall down is gravitational force, but the cause for its motion will not be considered. Therefore, kinematics is a branch of mechanics which deals with motion of bodies, in which force is not considered. Cause for the motion is not considered. So I repeat children, mechanics is a branch of physics in which motion of bodies is explained, will be discussed. Kinematics is a branch of mechanics which deals with the motion of bodies, but here the cause for the motion or the force which is applied on the body is not considered, children. Is it okay? Now in this, the very first terminology which we are going to learn is rest. What is rest, children? If there is no change in position, if there is no change in position, with respect to time and surroundings, then we say the body is said to be in rest. Next, I repeat, if there is no change in position of a body with respect to time and surroundings, then we say the body is said to be in rest position. Now, motion. If there is change in position, of the body with respect to time and surroundings, then we say the body is said to be in motion. For example, we'll take one example here. Let us consider a train. In a train, A and B are sitting. Let us consider a train in which A and B are sitting. C is a person who came for giving send-off. C is a person who came to give send-off for them. Now, A and B are sitting in a train. What is the state of A with respect to B? Rest position. What is the state of B with respect to A? Rest position. I repeat children, B is in rest with respect to A. A and B are in rest with respect to each other. Now, train started moving. Train started moving. A is in motion with respect to C. B is in motion with respect to C. C is in motion with respect to A. C is in motion with respect to B. I'll make it very clear, children. When the train is in rest position, A is in rest with respect to B, B is in rest with respect to A. When the train is moving, then also A is in rest with respect to B, B is in rest with respect to A. But while the train is moving, A is in motion with respect to C. B is in motion with respect to C. That means with respect to what we are speaking, with respect to what surroundings we are speaking, accordingly the state of the body will change. With respect to what surroundings we are speaking, the state of the body will change. That surroundings with respect to which body we are speaking, with respect to the body, with respect to the body. We are speaking with respect to which surroundings we are speaking, that is known as frame of reference. Or reference body. That with respect to what we are speaking, with respect to which body we are speaking, that is known as frame of reference or reference point or reference body. Is it clear, children? I will repeat once again. This already we have learned in CBSE. If there is no change in the position of the body with respect to time and surroundings, then it is rest. If there is change in the position of the body with respect to time and surroundings, then it is motion. Here, A and B are in rest positions with respect to each other. That means A is in rest with respect to B. B is the frame of reference. B is in rest with respect to A, then A is the frame of reference. A and B are in motion while the train is moving with respect to C, then C is the frame of reference. I hope it is clear, children. I hope it is clear. Next, we'll go with one more example. One other example which is like here an aeroplane. Suppose a stone is thrown from an aeroplane. A stone is dropped. A stone is dropped from the aeroplane. How it will fall, children? It will fall in a straight line. That is with respect to pilot. With respect to pilot. How it will be? Straight line. Suppose if the same stone is observed by the observer on the ground, if the same stone is observed by the observer on the ground, then it will be observer on the ground. Then it will be a curved line which we call it as a parabola shape. Curved line. It will be like this. That is, we call it as a parabola. What does I want to say from this? That is, a stone is dropped from the aeroplane. With respect to pilot, he is observing that stone is falling straight line. But a person who is on the surface, land surface on the ground, is observing that a stone is dropping from the aeroplane and it has taken a parabolic path. That means the path changes with respect to the reference point. The path will be different with respect to reference point. That means we call it as path is relative. Path is relative. Children, I told you already, absolute rest, absolute motion never exists. Absolute, which does not depend. Absolute means it does not depend on other thing. Absolute rest, absolute motion does not exist. Rest and motion both are relative terms. That means they depend on each other. Rest and motion are relative terms. I hope it is clear, children. Once again we will have this. So rest means no change in position with respect to time and surroundings. Motion means change in position with respect to time and surroundings. Absolute rest does not exist. Absolute motion does not exist. Rest and motion are relative terms. Suppose two persons are sitting in a train and a person is observing them. A is in rest with respect to B. B is the frame of reference. B is in rest with respect to A. A is the frame of reference. Now train is moving, C is observing them, A and B are in motion. Then with respect to C, C is the frame of reference. With respect to C, A and B both are in motion. Even though train is in moving, A is rest with B, B is in rest with A. That means frame of reference changes, the state of the body also changes. Now one more example like aeroplane. Airplane is flying in the sky. A stone is dropped from the airplane. The pilot watches it. The pilot sees it. The stone is falling straightly. With respect to pilot, it's a straight line. Suppose an observer, another person is observing the same stone from the ground. He feels that the stone is taken the parabolic path, the curved line, the parabola path. That means with respect to pilot, that is frame of reference is pilot here. With respect to pilot, it has taken a straight line. With respect to ground, that is with respect to the observer, with respect to this frame of reference, it is parabola. And hence I say here, the path taken by the stone is also relative. I hope it is clear, children. With this, we have completed concept 1 half part. Other half part is types of motion. What already I have read, but just we will have a look over the different types of motion. Types of motion. What types of motion we have, children? The very first type of motion is translatory motion. First one is translatory motion. If a body moves as a whole, when a force is applied, then it is said to be translatory motion. If a body moves as a whole when force is applied, every point of the body moves as a whole, then such a motion is known as translatory motion, which is divided into rectilinear motion and curvilinear motion. What is rectilinear motion? What is curvilinear motion, children? Come on, you just have a revision over this. A body moves in a straight line, then it is rectilinear motion. If a body moves in a curved path, then it is curvilinear motion. Any body moving on a straight road is a rectilinear motion. Any body taking a turn, a car taking a turn, a vehicle taking a turn, curved path is a curvilinear motion. Next one is circular motion. If any body moves in a curved path, then it is a circular motion. That is, any body moves in a circular path like this. Any body moves in a circular path, then it is a circular motion. If a body takes a circular path, then it is a circular motion, children. Now, in this part only, we will learn about rotatory motion. That means any body rotates on its own axis. I can say like spinning of a top. Rotating. Earth rotating on its own axis. As rotation. Or spinning of a top. Also considered as a rotatory motion. So what is rotatory motion? Any body rotates on its own axis is called rotatory motion. If any body takes a circular path, then it is a circular motion. Then we read regarding oscillatory motion. Oscillatory motion means The motion executed by pendulum, simple pendulum, or cradle swing. You might have seen the children swinging a cradle swing comes under the oscillatory motion, or the pendulum also execute oscillatory motion. What is oscillatory motion? The to and fro motion of a body on its mean position is known as oscillatory motion. Then comes vibratory motion. All musical instruments will execute vibratory motion. All musical instruments will execute vibratory motion. If you pluck a string, it will start vibrating, giving you the sound. It is all musical instruments will show the vibratory motion. Then comes periodic motion. What is periodic motion? I told you periodic motion is a special feature. It's a different, it's a special feature. What is periodic motion? If the path repeats, if there is a repetition of the path in equal intervals of time, if the path repeats within equal intervals of time, then it is called periodic motion. Equal intervals of time. It is periodic motion. I repeat, children, if the path repeats within equal intervals of time, then it is periodic motion. Again, we come across, for periodic motion, we can take the examples of rotation of the earth, revolution of the earth, movement of hands in a clock. All these are the examples of periodic motion. Then we'll come for the combination of motions. We have taken the example of drilling machine, combination of motions. Riding a bicycle also will come under that. A ball rolling on the ground also will come under this. So in all these kinds of motion, you'll be seeing 2 or 3 types of motions. It's a combination of motions. And random motion. No particular type of motion will be seen in random motion. Like the butterfly flying in the garden, the dog chasing a cat chasing a rat, mosquito flying. That is different kinds of randomly the type of motion will be changing, and hence we call it as random motion. Is it clear, children? So these are the different types of motions which we have discussed already. So we'll have once a glance types of motion. Translatory motion. If a body moves as a whole, complete body moves upon the application of force, then we say translatory motion. It is divided into rectilinear motion, curvilinear motion. If a body takes straight line path, then it is rectilinear motion. If a body takes curved path, then it is curvilinear motion. Circular motion. If a body moves in a circular path, then it is a circular motion. If a body rotates on its own axis, then it is rotatory motion. Oscillatory motion. If a body makes oscillations, the to and fro motion of a body on its mean position is oscillatory motion, like swinging of a cradle swing, pendulum, like this. Vibratory motion, that is you will be seeing in musical instruments, the to and fro motion of the body on its mean position is vibratory motion only. Here the body will move as a whole, here the body will not move as a whole. That's the difference between oscillatory and vibratory. I repeat, in oscillatory motion, the body moves as a whole, whereas in vibratory motion, the body will not come out of its position, will be moving, making vibrations on its main position only. Periodic motion, if there is a repetition in the path within equal intervals of time, then it is known as periodic motion. If the path repeats within equal intervals of time, then it is periodic motion, like rotation of the earth, revolution of the earth, like this. Combination of motions. If you see riding a bicycle, you'll be seeing on a straight road, it executes rectilinear motion, it executes rotatory motion of the wheel, rotation wheel. Like this, you will see 2 different motions there. Drilling machine, rectilinear motion, as well as rotatory motion. So rotation of the earth, revolution of the earth as a combination of that rotation and revolution is a combination of the motion. So you will be seeing combination of motions in certain cases. Next, random motion. No particular motion will be executed here, children. So you cannot identify. Randomly it will be continuously changing its type of motion, and hence it is a random motion. Children, with this we have completed our concept 1 of kinematics, children. I hope you understood, children. Thank you, children. We'll see you tomorrow. Thank you.